In this example, we have 11x squared plus 8x minus 2 over x cubed plus x squared. This denominator, if you factor out an x, actually you factor out an x squared because they both have at least two x's in common. So let's factor out x squared. X cubed divided by x squared is x. X squared divided by x squared is 1. So that leaves us two factors. This one is actually a quadratic factor. You could also, let's just leave it as a quadratic factor. Now, in the previous video, anytime we've had a linear factor, like this x plus 1, it's a linear factor because it's x to the first power. We create a fraction. Your numerator is always 1 degree lower. So from a linear, you go down a degree, that's a constant. And that's the way it was in the entire first video. We always had a constant as a numerator because our denominator was linear. But if you have a quadratic denominator, then you build a degree less, which makes it a linear. And a linear numerator will have an x term and a constant. Just be very careful. So our x squared fraction is actually going to need a linear numerator, and our linear fraction will need a constant for its numerator. Multiply both sides of this equation by x squared times x plus 1, and you'll get ax plus b times x plus 1, c times x squared, and then since our original fraction has both factors, they totally cancel, and that's why you end up with a numerator. So it's a numerator equals a crisscross pattern. All right, let's let x be 0, and this will, again, we're going to do this equation here, and we're going to randomly pick some x's to try to solve for a, b, and c. If we let x be 0, that gives us negative 2 equals, if x is 0, the a term disappears, so that's b times 1, telling us that b equals negative 2. We solve that equation for b. Now, let's pick x equal negative 1. Substitute negative 1 into all these x's, and that's going to give us a 1. A times negative 1 plus b, that's negative a plus b. Negative 1 plus 1 is 0, so that zeroes out this block. Negative 1 squared times c is positive 1c, so that tells us c has to be 1. So far, we're in good shape. All we lack is a. Now, because these two factors are only zeroed out when x is 0 or x equals negative 1, I've already exhausted the easy choices for x. I'm just going to randomly pick positive 1 because it's an easy to work with number. Substituting 1 into all these x's, we get 17 equals a times 1 plus b, that's a plus b, times 1 plus 1 is 2. 1 squared times c, that's c. Now, luckily, we know b and c from the steps above, so we replace b with negative 2, and we replace c with a 1. So c becomes 1. Distributing, that's 2a times, and then we have a plus 2 times negative 2, because that b is negative 2. So distribute the 2, replace b and c with their values. And then, solving for a, we have 2a minus 4 plus 1, that's negative 3. So 2a minus 3 is equal to 17. Add 3, that makes 20. Divide by 2, and that gives us 10. So at this point, we have a equals 10, b equals negative 2, and c equals 1. Telling us, look at the very top right of your screen, that we have 10x minus 2 over x squared plus 1 over x plus 1. Now I'm going to go down and reinvestigate that. All right, so I just copied our original fractions after they're decomposed into their factors. 10x minus 2 over x squared, which is what I highlighted up above, plus 1 over x plus 1. Because this can be broken down a little farther, 10x over x squared makes 10 over x, and negative 2 over x squared, well, that's as far as that one will reduce. We actually can decompose the original problem into 3 smaller and separate fractions. When we start integrating, it's going to be very handy to have smaller separated fractions. They're easier to integrate. In this last example, we have 7 minus x squared over 5x cubed plus x. This denominator, if we factor out an x, we have 5x squared plus 1 remaining. So this is the factored form of the original denominator. X is a linear factor, so its fraction will catch a numerator that's a constant, a linear denominator, constant numerator, because you always go 1 degree less. A quadratic denominator will have a linear numerator, x term and a constant. Multiply both sides by your least common denominator. That leaves 7 minus x squared. Crisscross on this other side, that's a times 5x squared plus 1 plus bx plus c times x. The easy choice initially is going to be 0. 0 will cancel out one of your blocks quickly. So this will be the equation we plug our x's into, and we'll have to be a little creative. Starting with 0, that's the easy choice. Plug 0 into this equation, you get 7 equals, this goes to 0, so 1a. If x is 0, this entire block back here goes to 0, so that leaves you with a equals 7. Randomly pick a different number. I chose 1 just because it's easy to work with. Substituting 1 into this equation, that leaves you with 6 equals 6a. B plus c times 1, that's b plus c. 6a plus b plus c equals 6. We know that a is equal to 7, so 6a makes 42. Subtract 42 from both sides, and that tells us negative 36 is the sum of b and c. Pick a different x value, sub it into the equation. I chose negative 1 because it's easy to work with. You can pick other numbers like 2 or negative 2. Just pick unique x's to sub in. Substituting in negative 1, we're going to get 6 equals 6a. Because x is negative 1, that's a negative b plus c times negative 1. Negative b plus c times negative 1. Distributing the negative 1 and replacing a with 7, that gives us 6 equals 42 plus b minus c. And subtracting 42 from both sides gives us the difference between b and c has to be negative 36. Well, if we add these two equations that I put a rectangle around, if we add them up, negative 72 is equal to 2b plus 0c. So that tells us that b has to be negative 36. And c is equal to 0. It's the only way to make both equations true. Let's go back to the top. Actually, hang on, let me see. Nope, never mind. I have it written down here. We had a over x. A was 7, so our first fraction is 7 over x. And then we had plus bx plus c over this denominator. Well, bx is negative 36x. C was 0, so we just don't have a constant to write. And then this is the decomposed form of the original problem.